The great illusion of a water park is controlled danger, but control is a fragile concept. We are about to analyze 6 recorded incidents where a hidden flaw in the steel, the wiring, or the very design turned a manufactured thrill into a fatal reality. This is an educational examination of real events presented as a cautionary tale. Inside Moscow's Transvalpark on February 14, 2004, was a thick, artificial fog of chlorine and high-octane humidity that made the Russian winter outside feel like a distant memory. Inside the massive glass and concrete dome, the temperature was a steady 30 degrees Celsius, while just inches away on the other side of the glass, the city was shivering in a brutal -20-degree deep freeze. This was the premier water park in the Yasenevo district, a 5-story tropical paradise designed to provide a total escape from the gray reality of the capital. For the hundreds of adults celebrating Valentine's Day, the park represented the pinnacle of modern luxury and safety. They drifted in the lazy river, relaxed in the saunas, and walked across the tile floors in nothing but swimsuits, completely unaware that they were standing beneath a structural disaster waiting for a trigger. The roof of the park was an engineering marvel known as a thin-shell concrete dome, spanning over 5,000 square meters without a single central pillar to hold it up. It was designed by the famous architect Knott to look like a giant, floating concrete bowl turned upside down. But this design had a hidden flaw that was being worsened by every minute of operation. The extreme humidity from the pools rose to the ceiling where it hit the freezing exterior shell, causing constant condensation. This water seeped into the microscopic cracks in the concrete and reached the steel support cables inside. Over time, these steel tendons began to rust and weaken, a process that was invisible to the naked eye. On this specific Saturday evening, a heavy, wet snow had been falling for hours, adding hundreds of tons of additional weight to the already struggling roof. Among the crowd was Mikhail, a 32-year-old manager who had come to the park to escape the stress of his work week. He was standing near the edge of the wave pool at exactly 7:15 p.m., looking at the bright lights reflecting off the water. The transition from peace to catastrophe happened in a fraction of a second. A sharp metallic snap echoed through the hall, a sound so loud it cut through the music and the splashing water. This was the bifurcation point where the structural integrity of the dome finally surrendered to gravity. The main support ring failed, and the entire 5,000-ton concrete shell began to slide downward. Time seemed to slow down as the massive structure descended. First, the perimeter glass walls exploded outward as the weight of the roof crushed the frame, sending millions of razor-sharp shards flying through the air like a crystal storm. Then, the artificial lights flickered and died, plunging the tropical paradise into a terrifying gray twilight. Mikhail had no time to run. He could only watch as the sky itself seemed to fall. The physics of the collapse were absolute and unstoppable. When the concrete slabs hit the pool area, the water did not act as a cushion. It became a solid wall that transmitted the force of the impact. The style of the event shifted from a recreational accident to a forensic scene in an instant. The victims in the direct path of the falling debris suffered immediate blunt force trauma to the cranium and spinal columns. The clinical reality was that the massive weight caused the structural compromise of the thoracic cavities, leading to fatal internal injuries and the immediate cessation of cardiac function upon impact. For those who were not hit by the concrete, a new threat emerged. As the roof vanished, the freezing Russian air rushed into the heated building at high velocity. The sudden contact between the -20-degree air and the warm pool water created a violent, blinding white steam that filled the ruins. People in nothing but swimwear were suddenly standing in a frozen wasteland of jagged concrete and twisted steel. The human world of the tropical vacation was replaced by the objective force of a Russian winter. When rescuers arrived, they found a silent landscape of white mist and red-stained snow. They had to navigate a forest of hanging metal and glass that looked like a giant broken machine. They found a single, waterproof watch on the floor, its glass cracked, but its internal mechanism still ticking away, showing the exact time the dream ended. The investigation later revealed that the design had not accounted for the way the metal would corrode in such a humid environment. The Transvalpark disaster led to a total change in how large-scale public buildings were inspected in Russia. The park was eventually demolished, leaving behind only the cold memory of a night when a tropical paradise became a concrete trap. The site now holds a small chapel, a quiet artifact of the moment when human engineering failed against the simple, heavy reality of snow and rust. June 2, 1997, at Waterworld, USA in Concord, California. The park was crowded with students from Napa Valley High School who had come to celebrate their graduation day. For these seniors, the afternoon was supposed to be the final chapter of their teenage years before the formal ceremony scheduled for that very evening. The atmosphere was filled with the smell of chlorine, sunblock, and the constant rhythmic splashing of water. Among the many attractions, the Banzai Pipeline was a favorite. It was a high-speed water slide consisting of a long fiberglass tube supported by a network of steel beams and wooden platforms. The engineering behind the slide was simple and effective for its intended use. It was built to handle the weight and momentum of one person at a time, roughly 300 pounds of maximum load. This was the safety norm that every visitor was expected to follow. But on this day, a group of 33 seniors decided to ignore the rules in search of a collective thrill. They planned to crowd into the slide all at once to form a human chain or a living train. They shoved past the lifeguards and crowded onto the upper platform, driven by a sense of youthful invincibility and the belief that the park equipment was indestructible. As they began their descent, the physics of the situation turned lethal. 33 young adults, with a combined weight of nearly 5,000 pounds, entered the fiberglass tube simultaneously. This was not a gradual increase in stress. It was a massive, concentrated blow to the structure. The fiberglass was never designed to act as a bridge for the weight of a heavy SUV. As the lead students reached a sharp curve halfway down the slide, the entire assembly began to groan. The steel bolts holding the sections together reached their sheer strength limit. This was the bifurcation point where the human world of fun hit the cold reality of material science. The fiberglass did not just crack, it suffered a total structural failure. With a sound like a gunshot, the middle section of the slide buckled and snapped. Time seemed to dilate for the students as the floor beneath them simply disappeared. The section of the tube fell 30 feet toward the hard concrete and landscaping below. The transition from a high-speed ride to a free fall was instantaneous. The students were no longer part of a celebration. They were falling objects governed by the laws of gravity. The impact with the ground was the moment of irreversible interaction. The style of the scene shifted from a recreational accident to a forensic report. 18-year-old Quimby Galati was among those at the front of the chain, and she bore the full weight of the falling mass above her. The clinical reality was grim. Upon impact, the victims experienced extreme blunt force trauma to the skeletal structure and internal organs. The sheer kinetic energy caused the structural compromise of the thoracic cavities and significant spinal injuries. For Quimby, the trauma was too severe for the body to sustain, and cardiac function ceased almost immediately upon impact. The pool area, once filled with music and laughter, was suddenly silent, broken only by the sound of water continuing to flow from the broken pipe above, splashing onto the wreckage. Dozens of other students lay scattered across the concrete with broken limbs and internal bleeding. The artifact of the tragedy was the graduation ceremony held later that evening. In the school gymnasium, several chairs in the front row remained empty, decorated only with graduation caps and gowns that would never be worn. The graduation was not a celebration of the future, but a somber gathering to process the sudden loss. The bonsai pipeline was eventually removed from the park, leaving a permanent gap in the skyline that served as a reminder of the day when a simple plastic slide became a lesson in the limits of engineering. The park faced numerous lawsuits, and the incident led to a nationwide overhaul of how water slides are inspected and how crowd control is managed on high-capacity attractions. The investigation proved that the slide was structurally sound for its intended purpose, but it could never survive the one variable the engineers could not account for: the collective recklessness of 33 people who believed they were stronger than physics. The silence that followed the crash at Waterworld USA became a permanent part of the park's history, a cold statement of fact that when the breaking point of a material is reached, it does not matter how much potential a life has or how many plans were made for the future. The afternoon of March 21, 1999, at Six Flags Over Texas, was defined by the relentless industrial drone of massive electric pumps and the artificial roar of thousands of gallons of water surging through a man-made concrete canyon. This was the Roaring Rapids, an attraction designed to manufacture the excitement of a dangerous mountain river within the highly controlled environment of an Arlington amusement park. The ride utilized heavy, 12-person circular rafts that each weighed over 2,000 pounds. These vessels were wrapped in a massive, air-filled rubber ring meant to ensure the boat remained high in the water and bounced safely off the concrete walls. This engineering standard was supposed to make the ride impossible to sink or flip. It was a verified safety system that had operated millions of times without a major failure. 28-year-old Valeria Cartwright was sitting in one of these molded plastic seats, buckled in and enjoying a Sunday trip with her family. To her, the ride was just a series of splashes and spins, a harmless diversion on a bright Texas day. She had no reason to doubt the physics of the boat or the reliability of the concrete track beneath her. However, the system was operating with a hidden, dangerous variable. The water levels in the channel were unusually low that afternoon, a technical detail that changed the way the currents interacted with the heavy rafts. As Valeria's boat entered a narrow stretch of the course, a sudden mechanical surge from the main pumps sent a rogue wave of water down the channel. This wave hit the raft at a specific angle that the designers had never anticipated. Instead of riding over the crest, the front edge of the heavy raft caught the concrete lip of the riverbed, while the surge of water lifted the back end. In an instant, the raft began to tilt past the point of no return. There was a brief moment of terrifying silence as the 2-ton vessel hung vertically in the air before. The weight of the water and the force of the current flipped it completely upside down. The transition from the sunny surface to the dark, turbulent water below was immediate and total. Valeria and her family were suddenly trapped in the chaotic space beneath the heavy hull. This is where the primary safety feature of the raft, its high buoyancy, became a lethal mechanism of entrapment. The massive inflatable ring was filled with hundreds of cubic feet of air, which now fought to reach the surface with incredible force. Because the raft was inverted and squeezed between the narrow concrete walls of the ride, this upward buoyancy created a crushing downward pressure on everything trapped beneath it. Valeria was pinned against the rough concrete floor of the channel by the weight of the boat and the thousands of pounds of upward force from the air tubes. The mechanical reality of the situation was that the boat had become a pressurized lid on a concrete trap. The forensic analysis of the event describes a situation of extreme physical confinement where the human body was subjected to forces it was never meant to withstand. In the darkness beneath the raft, Valeria experienced a rapid onset of acute respiratory compromise. As the lungs were unable to access oxygen, The biological systems of the body began to fail in a predictable linear sequence. The police and medical reports later categorized the cause of death as fatal respiratory arrest due to prolonged submersion and the mechanical compression of the thoracic cavity. Despite the desperate efforts of her husband and other passengers to lift the boat, the physics of the buoyancy and the water pressure made the 2-ton raft impossible to move by hand. It took park staff and emergency responders several minutes to finally deactivate the massive pumps and stabilize the vessel. The aftermath of the tragedy was a scene of chilling silence. The once roaring rapids were suddenly still, and the only sound was the distant music of the park's midway. The inverted raft sat motionless in the shallow water, an empty fiberglass shell that had served as a cage. A single plastic souvenir cup floated near the scene, a mundane object that remained as a silent witness to a life cut short by a mechanical error. The roaring rapids was immediately shut down for an extensive federal investigation that lasted for months. This investigation led to a total overhaul of water park safety standards, including the installation of emergency air pockets, underwater cameras, and automatic sensors that would shut down the pumps if water levels dropped even a few inches. The incident proved that in the world of heavy machinery, the very tools we use for safety can become weapons when the laws of physics are pushed out of their normal parameters. Today, Valeria Cartwright's story is documented as a grim lesson in fluid dynamics and the unforgiving nature of industrial engineering. It serves as a reminder that even in the most sanitized and controlled environments, the raw power of moving water and heavy machinery follows its own cold logic, a logic that does not account for human plans or the safety of a Sunday afternoon. The summer of 1982 in Vernon, New Jersey was a heavy, humid season, defined by the chaotic and unregulated energy of Action Park. This was a sprawling monument to extreme thrills, a place where the standard rules of engineering and safety seemed to be treated as mere suggestions. The air at the park was a thick mixture of sunblock, hot pavement, and the constant metallic smell of churning pool water. Among the park's most popular attractions was the kayak experience, a man-made river course designed to give visitors the feeling of navigating a wild mountain stream in a small plastic boat. The water was not moved by the natural slope of the land, but by a series of massive submerged electric fans bolted directly to the bottom of the concrete pond. These high-voltage motors were the hidden heart of the ride, spinning large blades to create a powerful artificial current. The technical plan for this attraction relied on the absolute integrity of the waterproof seals that kept the lethal electricity away from the guests. For the thousands of people who visited that July, the ride was just a refreshing way to fight the heavy heat of a suburban afternoon. Jeffrey McManus was a 27-year-old man who loved the outdoors and physical activity. He arrived at the park on a bright afternoon, looking for a challenge in the artificial rapids. He settled into a narrow yellow kayak and began to paddle through the concrete channel. The sun was bright on his shoulders, and the environment was filled with the sounds of shouting crowds and the rhythmic hum of the heavy machinery beneath the surface. Jeffrey was focused on the movement of the water, completely unaware that he was floating directly over a mechanical disaster. One of the underwater fans had developed a fatal defect. The constant vibration of the motor and the corrosive chemicals in the pool water had eaten through the protective casing, exposing the live, high-voltage wires to the surrounding water. This section of the pond had become a silent, electrified zone that looked exactly like the rest of the safe attraction. When Jeffrey's kayak hit a small wave and flipped over, it was a common occurrence that happened dozens of times every day. He surfaced, shook the water from his face, and reached down to find his footing on the concrete floor so he could stand up and right his boat. The water was shallow, barely reaching his waist, but as soon as his feet made contact with the bottom near the faulty motor, his body became a bridge for the escaping current. The impact was silent and immediate. Jeffrey did not splash or call for help. His muscles locked into a state of total involuntary contraction. The physics of the event were simple and deadly. The water, acting as a highly efficient conductor, allowed the high-voltage electricity to flow directly through his internal organs. The medical reality was that Jeffrey experienced a fatal electrical trauma. The current caused a total disruption of the heart's natural electrical rhythm, leading to an immediate state of lethal cardiac arrhythmia. The high-voltage interference resulted in the total cessation of respiratory function and a massive neurological collapse. A lifeguard and several other guests saw him go rigid and rushed into the water to pull him out. They were also hit by the current, feeling sharp, agonizing shocks that threw them back and alerted them that the water itself had become a weapon. It took several minutes for the park staff to find the master switch and cut the power to the massive motors. By the time the current was deactivated, the damage to Jeffrey's biological systems was irreversible. He was pronounced dead shortly after being removed from the water. The aftermath of the tragedy was a landscape of sudden, heavy silence. The kayak experience was drained of its water and never allowed to operate again. The investigation that followed proved that the park had failed to maintain the equipment and had ignored basic electrical safety codes. Jeffrey's death became a central part of the legal battles that would eventually define the legacy of Action Park as the most dangerous theme park in American history. The physical evidence recovered from the bottom of the pond was a rusted, cracked motor casing that had allowed a hidden current to end a life. Today, the story of Jeffrey McManus is a grim documentation of the fact that the most dangerous threats are the ones that are invisible to the human senses. The water looked calm and safe, but it was a conductor for a force that could stop a human heart in a fraction of a second. This tragedy led to a total overhaul of the National Electrical Code for all public water attractions, ensuring that every submerged motor today is protected by multiple layers of fail-safe technology. But for the family of Jeffrey McManus, those changes came only after a simple summer day ended in a silent, electrified trap. The empty, dry concrete channel of the ride remained for years, a cold reminder that when high-voltage machinery and water meet, the margin for error is zero. In the late summer of 2001, the skyline of Knott's Berry Farm in Buena Park, California, was dominated by a massive structure of neon blue steel known as Perilous Plunge. This attraction was an engineering giant, marketed as the tallest and steepest water descent ride in the world. It featured a towering 115-foot lift hill that dropped into a nearly vertical 75-degree slope. The ride was designed to create a specific physical sensation called negative G-force, which is the feeling of weightlessness that lifts a passenger out of their seat during a sharp drop. To prevent riders from being thrown from the boats, the engineering team installed a restraint system consisting of an adjustable lap bar and a supplemental T-shaped seatbelt. This system relied on a very specific physical requirement. The bar had to pin the rider's thighs firmly against the seat to lock them in place. The safety of the entire ride was based on this single point of contact. On September 24, 2001, 40-year-old Lori Mason Larez arrived at the park with her family. She was a mother of 5 who had come to the park for a day of celebration and fun. Lori was a woman with a larger physical frame, a detail that the ride's safety geometry was not fully prepared to handle. As she sat in the 24-passenger boat and pulled the lap bar down, the mechanism clicked into place, signaling to the ride operators that she was secure. However, because of her body shape, the lap bar rested against her stomach rather than her thighs. This created a significant invisible gap between her pelvis and the actual restraint. To the computer system, the ride was safe to start. In reality, Lori was sitting in a seat that offered her no physical grip. The boat began its slow, clanking climb up the lift hill, the heavy sound of the metal chain echoing across the lagoon below. The air was warm and smelled of sunblock and stagnant water. When the boat reached the summit, it paused for a split second at the edge of the drop. At exactly 4:30 p.m., the boat was released into the abyss. As it accelerated down the steep slope, reaching speeds of 50 miles per hour, the negative G forces took over. Every passenger was lifted upward by the sudden change in momentum. For most, the lap bar caught their legs and held them down, but for Lori, there was nothing to stop her upward movement. As the boat plummeted, she was lifted completely out of her seat. There was a brief moment where she was suspended in the air, separated from the vessel, before gravity and forward momentum took control of her trajectory. Lori was ejected from the boat, falling over 100 feet through the air while the rest of the passengers screamed in horror. The transition from a standard thrill ride to a physical catastrophe happened in the blink of an eye. The boat hit the water at the bottom, creating a massive splash, but Lori's seat returned to the station empty. The mechanical interaction was replaced by the cold reality of physics and impact. Lori struck the water and the submerged concrete supports of the ride with extreme kinetic energy. The medical reality of a fall from that height is absolute. Upon impact, she suffered fatal blunt force trauma to her entire skeletal system. The clinical report detailed multiple complex fractures to the cranium and spinal column, along with massive internal hemorrhage and the structural compromise of the vital organs. The impact caused the immediate cessation of cardiac and neurological function. The park was immediately plunged into a heavy, suffocating silence as guests realized what had happened. Perilous Plunge was shut down and surrounded by police tape as state investigators began to examine the boat and the restraint system. The investigation proved that the lap bar was fundamentally unsafe for individuals who did not fit a very narrow physical standard. It also revealed that the negative G forces produced by the 75-degree drop were too powerful for a simple lap bar to manage safely. This tragedy forced the entire theme park industry to rethink how they secure passengers on high-drop attractions. Across the world, similar rides were closed to install over-the-shoulder harnesses and 4-point seatbelt systems that could accommodate all body types. Knott's Berry Farm eventually settled a major lawsuit with the family, and the ride itself became a symbol of engineering failure. After years of mechanical problems and a permanent stain on its reputation, the Blue Tower of Perilous Plunge was finally demolished in 2012. Today, the lagoon where Lori fell is a quiet part of the park, but her story remains a documented warning about the dangers of a one-size-fits-all approach to safety. The artifact of that day was the boat that returned to the dock with the lap bar still locked over an empty space, a silent testament to the moment when the laws of physics found the gap in the design and turned a recreational descent into a fatal ejection. It serves as a reminder that in the world of high-speed machinery, the margin between a thrill and a tragedy is often measured in just a few inches of steel and belt. In the summer of 2002, the fields of Somerset, England, were home to a small, independent attraction known as the Middlemore Waterpark. This was not a polished corporate park with certified steel rides. It was a rustic, low-budget place where the air smelled of damp earth and murky lake water. The park's main draw was a massive, hand-built wooden machine that stood on the edge of the main lake. It was a medieval-style Trebuchet, a giant siege engine historically designed for a single purpose: to hurl massive rocks with enough force to smash down castle walls. The park's owners, two local men named David and Richard, had repurposed this weapon of war into an extreme sport attraction. They offered to launch paying customers through the air, promising a thrilling flight that was supposed to end safely in a large net suspended over the water. The entire operation was based on amateur calculations and backyard experiments. There were no certified engineers, no official safety inspectors, and no formal risk assessments. 19-year-old Kostadin Kosta-Yankov, an Oxford University student, arrived at the park on a bright July afternoon. He was an adventurous young man looking for a unique thrill, a story to tell his friends back at school. He saw the massive wooden machine not as a weapon, but as a one-of-a-kind ride. He paid his fee, signed a waiver, and placed his trust in the operators, assuming that no one would be allowed to run a public attraction if it was not fundamentally safe. As Costa was strapped into a harness at the end of the Trebuchet's long throwing arm, the giant wooden frame loomed over him like a skeleton. This was the moment where his trust in the system collided with the unforgiving reality of physics. The operators released the massive counterweight, a heavy box filled with tons of rock and soil. With a deep groaning thud of stressed timber, the machine activated. Time seemed to stretch as Costa was whipped into the air. He accelerated from a dead stop to over 60 miles per hour in a fraction of a second, the G-force pressing him deep into the harness. For a brief moment, it was the ultimate thrill. He was flying, soaring through the summer sky with the green English countryside laid out beneath him. He could see the large white safety net suspended over the lake, a clear target that was meant to catch him. But as he reached the peak of his trajectory, a cold, sickening realization hit him. He was not heading for the net. He was flying over it. The amateur calculations were wrong. He was moving too high and too fast. The net was drifting away beneath him, a useless patch of white in the dark water. The transition from a recreational launch to a ballistic event was total and irreversible. Costa's flight path took him completely over the edge of the safety net. He did not clip the side. He missed it entirely by several feet. His body, now governed only by the laws of gravity and momentum, continued its arc toward the unprepared ground on the far side of the lake. The medical reality of the impact was absolute. Costa struck the earth with a velocity that the human skeletal system is not designed to withstand. Upon impact, he experienced fatal, blunt force trauma across his entire body. The clinical report detailed catastrophic fractures to the skull, spinal column, and thoracic cavity, along with massive internal hemorrhage resulting from the extreme deceleration. The impact caused the immediate cessation of all cardiac and neurological function. The crowd, which had been cheering seconds before, was plunged into a state of stunned, horrified silence. The massive wooden arm of the Trebuchet swung back and forth a few times before coming to a stop, its harness now empty. The safety net, the one piece of equipment designed to prevent this exact outcome, hung untouched and pristine over the water, a useless artifact of a failed plan. The park's owners were arrested and later found guilty of manslaughter. The investigation revealed they had no insurance, no official engineering plans, and had ignored multiple warnings from concerned locals about the machine's reliability. The tragedy at Middlemore Waterpark led to immediate and strict new regulations in the UK regarding amateur-built extreme attractions. The Trebuchet was dismantled and destroyed. Today, the story of Kosta Yankov is a grim documentation of what happens when human ego and amateur engineering attempt to bend the laws of physics. It stands as a stark reminder that some machines were never meant to carry people, and that the difference between a medieval weapon and a theme park ride is not intent, but a deep and respectful understanding of the cold, predictable math of a projectile in flight. The untouched net became the final silent symbol of a day when a young man paid the ultimate price for someone else's fatal miscalculation. These 6 cases prove that safety is a constant negotiation between design and human behavior. So who is the greater danger? The engineer who makes a single hidden mistake, or the public that consistently ignores the rules? Cast your vote in the comments below. If you value this kind of critical analysis, subscribe and activate the bell.